Okay, good morning, good afternoon, whatever time it is in your place, to everybody. So in this next hour, we'll give you a very short introduction to the OpenSARLab, which is a cloud-based training environment that we will be using to facilitate this INSAR course. The benefits of, I'll talk to you a little bit about what that is, why we built this environment, and what it is, what the benefits are, and how to use it, so that hopefully after this training, you are ready to attend in this SAR training to the full extent. So let's see. So the OpenSARLab environment that we are using for this class, we at the Alaska Satellite Facility built a separate deployment of the OpenSARLab environment, which is a cloud-based training environment. This deployment is located at https://unavgo.asf.alaska.edu. So please use this URL. And if you want, please go to that URL now and log into the service. Most of you, I think, already are signed up. As you may have experienced, it takes a few minutes to spin up, so you can spin up your instance now by going to this link. Once you are click this link, you should see a welcome screen that looks like this on the right-hand side here, and you will see that there is a sign-in button that you can use to sign into the environment. In brief, the OpenSARLab is a fully pre-installed and fully cloud-based processing environment. If you are familiar with SAR and INSAR processing, a lot of the processing is done using open source software tools. The ones that we will be working with in this course are the software tools ICE and MinPy. Those are fully pre-installed on the OpenSARLab. You also will find on the OpenSARLab a bunch of Jupyter notebooks that we'll be using to run through the class and do all the training exercises of the class. You should be able to access the OpenSARLab from any internet-enabled device that has a web browser. So you can do it from your iPad as well as from your laptop or from your PC. It doesn't matter what operating system you run. So you can equally access the environment on a Windows machine, or a Linux machine, or on a Mac. So all of those are equally usable. And I think it should work on every web browser. I haven't seen any web browser specific problems with it. The only issue we once had with somebody who has locked down his browser to an extreme amount, that caused one some issues, but otherwise any web browser should work. You'll see that the OpenSARLab sits in the cloud, and specifically it sits in the Amazon Web Services cloud. The choice of cloud provider has mostly to do with where the data are located. The idea is to place this environment directly next to the archive or close to the archive, so that data access is easy and quick in the cloud and doesn't cause any extra what's called egress or export fees that cloud providers usually charge you if you migrate data outside of a cloud environment. The OpenSARLab otherwise is fairly broadly installed. We actually have built an install that it's specifically done for this SAR course. It has a broad range of Python tools available, plus all of the software packages you will need. All of the environment is based on Python. So all of the code that you'll be seeing is also Python code. And as I said, it contains all the notebooks and software tools. This one I can skip. We have this training now, so you know this already. So the concept of the OpenSARLab in general is, the idea behind it is that you as the user, in this case as the attendee of this class, are sitting here on the bottom of this view graph. You are accessing a cloud-based computing environment that here sits in the Amazon Web Services cloud. We've built an environment, a class environment that is auto-scaling. So when you come into the class, an additional machine is being created and instances are being added as more and more students come into the classroom. So it's auto scaling. It scales up automatically, and it also scales down automatically. So if you leave the OpenSARLab environment at the end of a session, after a certain period of time, your instance is going to be shut down in a safe way. So all of the data is being stored, and the machine is being turned off. And the next time you come back, the machine will restart. As we said, it contains Python tools, GIS tools. It has some SAR tools on it that you need for this class. All of the background, if you're more technically inclined, is orchestrated using a variety of things. The orchestration of the lab is done via Jupyter Hub. The storage handling is via AWS EBS volumes and snapshots, if that's something that means anything to you. And we have Docker containers and Kubernetes clusters to manage the instantiation of different machines. What's also important is on the back end, all the notebooks that we are using, they're actually publicly available. So we pull all the content of the OpenSARLab from publicly available repositories. So the UNAVCO training repository is publicly available on a GitHub, on a GitHub account. Also, the environment is connected to data resources. So they're connected to all of ASF's data holdings, predominantly the Sentinel-1 data holdings of ASF, and also are connected to some of the value-added processed, the application-ready data services such as Griffin, which was a project between JPL and ASF to create data sets that are NISA-like. There's a large INSAR archive at ASF that was created in collaboration with JPL through the Griffin project. And we will actually pull some of these data sets, or we'll use some of the data sets that were created within Griffin in this course today. So briefly, how you get in. You should have hopefully seen this already. Let's see, I can bring up my chat. There are a few questions in the chat. I think Eric, are you on? Eric and Alex, Eric Lundell?
Yeah, I'm on.
Yeah, so if you see any questions that need responding, please respond to those in the chat also.
Well, just to let you know, for those, so the one question is, will the account be activated after the course, or do I have to sign up again at opensarlab.asf.alaska.edu? The NAVCO training here is separate from the standard OpenSARLab on the DAC account. So if you want to carry over for NAVCO, you have to create a new account at OpenSARLab.asf, and nothing will carry over. Actually, if you
so that's the conversation about sort of the end of life of the cluster. Let's have that conversation. Once we looked at the end of this training to talk about what to do when the course comes to an end. So for now, please use this deployment at https://unavco.asf.alaska.edu. Once you are there, click on the sign-in button. If you are entering the environment for the first time, you have to create a user account. Let's see if my browser responds. So first-time user, click on sign up and fill in the sign-up form that pops up. And important, try to make sure that you use the email address here that is associated with your UNAVCO INSA course registration. So when you registered for the INSA course, that's the email address that we have on file. Everybody that registered for the course is whitelisted on the OpenSARLab. So once you create an account, you can right away access it. The way we verify that you're the right person is by looking for your email address. So please use the email address that you used for registering for the INSA course. If you can't remember what that is, we'll figure it out down the road. But easiest is if you use that particular email address. So hopefully most of you have already done this and are already live on the environment. So once you are in the environment, you will see as a first screen, you see a server option screen. So in this case, having this option screen up is a little bit of a waste of a website because in this case we only have one server option available. This is not necessarily the case for all deployments of the OpenSARLab. There may be differently sized compute environments available. We may have to, we may build a different environment as we go on with the course, but for now you see this one environment that's available. It's called UNAVCO 2. It's automatically pre-selected. It tells you here what kind of machine that you're running. So it's an M5A 4X large. That's one AWS machine type. If you want to know what that exactly looks like, you can copy paste this in a browser and search for this in AWS, and you'll find some information on it. So there are virtual CPUs, 35 gigs of RAM, and 500 gigabytes of storage available. Is a question? Yes. Paul, are you still on? Or Gareth, can you paste in the repository for the UNAVCO GitHub?
Paste in the repository for the UNAVCO.
The link to the geosync repo.
Oh, yeah, I can do that.
You shouldn't really need it for this, but
No, yes, but I mentioned it earlier, so I caused the question, I guess.
Yeah, I can get that.
So we'll exercise this here in a second, but once you are in the environment, you will see a home screen that looks akin to what you see on this slide. The main part of this is by default a view that is similar to your Windows Explorer or your Mac Finder. It basically shows you all the folders that are on the environment. For this particular training, all the notebooks you need are in the folder geosync. And we'll go through this here in a second. So all of the information you need is in a geosync folder. Other items on this home screen is if you click on this new button, it allows you to open things like a terminal or create a new notebook. You can see which notebooks are running if you click on this running tab. I guess an important one is up here. There is a user docs link that I'll show you in a few seconds. If you have questions about how to use the OpenSARLab or how to use notebooks, you can click on this user doc links and it provides you some additional information. So I'm going to go through all of these items of the home screen here in a second. And I think that's mostly what I wanted to talk about before I actually show this off live. Just one more note is we will be using Jupyter Notebooks for this class, which is an open source way of sharing with you fully executable workflows. If many of you may have used Jupyter Notebooks before, if you haven't, in the end, the benefit is that it's a mix of code with instructions and explanations. So they create workflows that are fully executable, fully reproducible. So if I run this workflow on my machine, if you run that workflow on the OpenSARLab, you'll get the same output at the very end. So it's fully reproducible from one user to the next. If you are new to Python, you'll see that the code that we'll be looking at is Python code. If you haven't done much Python programming before, I think these notebooks are a very vanilla way or an easy way to get into the Python language because you have all the existing code already exposed. So if you wanted to build your own notebooks down the road, you can sort of steal or reuse all the code that's already in these notebooks. So you don't really have to start programming notebooks from scratch. You can leverage all the existing code that's already available in the variety of notebooks that you find online. And maybe lastly, if you have your own notebooks and you wanted to exercise them also in the OpenSARLab, one benefit of the OpenSARLab environment is that it is fairly broadly installed. So if you upload your notebook to the OpenSARLab, it in most cases may run out of the box or may run with only a limited amount of tweaks that you may have to apply to the notebook. And maybe I stop here and we'll actually go to the OpenSARLab. Bring my OpenSARLab up. And maybe, let's see, we have how many folks on now? We have 67 folks on. I hope you all were able to log into the environment. So let me log in here real quick, sign into the environment. I have my username and password here, signing in. And hopefully most of you have managed to get to this home screen. Can you maybe give me a show of hands who managed to get to this point? Most of you. Okay. Excellent. Lots of thumbs up. Great. If you have issues, please paste questions in the chat, and we'll try to help you out. Okay. So let me rehash one more time. When you are at this home screen, you can follow along a little bit. What's available in this environment and what the different buttons mean. So as I said, this main part of the OpenSARLab environment is basically a navigation screen that allows you to navigate through the different folder structures on the OpenSARLab. The main one that we will be using is the geosync folder. Another one that you might find interesting is the notebooks folder. In the notebooks folder, we have a bunch of other notebooks that we've collected over time. You can sort of navigate through that and see what all is available on the notebook lab. But for this particular course, the main one that we need is in this geosync folder. So if you click on that geosync folder, this is a clone of the geosync GitHub repository. Paul Rosen provided the link to the repository earlier today. So if you would compare that to the GitHub repo, you see that you have the exact same folder structure in here that you also have on the GitHub repository. So if you wanted to, you could also clone these notebooks to your local machine if you wanted to sort of archive them separately. The main set of notebooks that we'll need is in this folder that's called UNAFCO 2021. So if you click on that folder, you see all the different modules of the class. The modules that are called 0 point something, so 0.0 to 0.9, these are all sort of prerequisite pre-training notebooks that you can walk through. So those are all to be done before the course begins next week. And then the course itself begins with 1.0 and into the future. So they should be coordinated with the syllabus more or less correctly, so that you know which notebooks to run and which folders to look at as we go through the training. Okay, so I'm just going to pick one random subsection of the course. I'm going to click on 1.2 geophysical modeling. If you click on that particular set of the notebook environment, you'll see that this subfolder contains a number of things. It contains different notebooks. It contains, in this case, PowerPoint slides and PDF documents that you can either look at on here or download, and so on. Oh, maybe a little note here. If you go into the environment, you sometimes may see things like this, where you have a notebook that is duplicated. You see here there's a notebook that it's called UNAFCO INSAR minus geophysical modeling minus homework 2.ipy notebook. Oh, I should also say the Jupyter notebooks you can identify by the extension IPyNB, which stands for IPython notebook. You can also identify them by this little symbol in the front of it, the sort of the book-like symbol, which identifies, this icon identifies the notebooks that you can execute. Sometimes you see duplicates of these notebooks. You see this notebook is here twice. And once it shows up with this underscore in the date and time identifier at the very end. Can you see this, hopefully? What this means is that you have modified, I have modified this notebook. And since then, a new release of that notebook has come out. So the Git puller that runs when your instance starts, it always goes out and looks for new versions of notebooks or new notebooks that are available in the individual repositories that we pull from. So this notebook has been updated since I ran it. So what the Git puller does, it takes my notebook that I had modified, it stores it under a slightly different name with a date and time index at the very end, and then pulls in the new notebook. So the one that has the date and time extension on it, this is my notebook that I had modified. This way, the Git puller will never throw away any of the work that you have done. So in this case, I modified it and it's still saved on this environment so that nothing's lost. Anyway, so this is what you sometimes may see. If we update a notebook in the Git repository and you have already run this notebook, you will see a duplication like this. Okay, let's click on this UNAVCO INSAR minus geophysical modeling notebook. So just to show you what these notebooks look like. So it'll take a few seconds to load. So let me first talk about the structure of these notebooks. If you sort of scroll through this notebook and you click at individual parts of this notebook, you may see that there's a frame that shows up around the individual components of this notebook. Hopefully you see that when I go from one to the next. These frames indicate what in the notebook language are called cells. So a notebook is a sequence of individual cells, and each of these cells is doing different things. In the end, what we will be using in all of the notebooks that we have is we'll use two kinds of cells. There's one kind of cell, like this top one on the very top of the notebook, that are so-called markdown cells. You can see that this is a markdown cell here in this little drop-down menu on top of the screen, where it identifies this cell as a markdown cell. Markdown cells are cells that contain texts and visualizations and graphics and maybe equations. So they convey information that is interpreted as text. So we use those to provide information in between code cells to sort of tell you what the individual code cells are doing. So we have these markdown cells, and then in addition to those markdown cells, we have these cells here, which contain executable computer code. These cells are code cells. You can again see in this little drop-down menu on top that they are identified as code cells. And they contain executable code. In our case, the code is Python code, potentially mixed off and on with command line calls, but predominantly it's Python code in these code cells. And so we have a series of consecutive code cells. So notebooks are a sequence of cells that are to be executed and run in order. So you can run these individual code cells as you go through the notebook, and you do it one by one after the other in sequence. To run a code cell, you can click into one of these code cells, and you can click this button up here that says run. So if you do that along with me, you click run, you will see that this code cell is getting executed. You may see now that next to the code cell, there's this square bracket. This square bracket is now filled with a 1. This is basically an ascending numbering of the code cells as we execute them. So this is the first code cell we ran in this notebook, and it has the identifier 1 next to it. You see that the next code cell also has these square brackets next to it, but the square brackets are empty, indicating this cell has not yet been executed. So we can click onto this one and run this code cell again. When I click on this, I want you to focus on the square brackets. And when I click run, you should see very briefly that there is an asterisk shown in that square bracket. It actually is only very briefly. You may have seen that or not. So when the code cell is executing the code, you'll see a little asterisk symbol in these square brackets. In this case, the code cell ran very quickly, so you could only see that for like a fraction of a second. If you have a larger code cell that runs a bit longer, you would see an asterisk show up here. You'll also see something else on this interface. If you go to the top right corner, you see an empty circle right now, a gray empty circle. This corner up here identifies, first of all, which kernel or environment this notebook is running in. This is running in an environment that we specifically built for UNAFCO, for the UNAFCO course. And next to it, it shows an empty circle. When the circle is empty, it means that the kernel that's running this notebook is currently idle. There's no process running at this particular time. When you run a code cell, this empty circle will be filled, indicating that the kernel is currently busy. That can be useful if you run a code cell that does a lot of work and may run for a while. Sometimes if it runs for a really long time, you want to check if the kernel is still busy or if the code may be broke or if something else happened. So you can always look at this top right corner to identify whether the kernel is currently busy or whether the kernel is currently idle. So talking about this kernel up here, the notebooks that we will be using should all be run in a kernel that is called UNAFCO, in an environment that is called UNAFCO. Most notebooks, by the time we get to them, should be set to the UNAFCO kernel. If you open a notebook that isn't yet set to the UNAFCO kernel, please change the kernel to UNAFCO. So when you open a notebook, look at this top right corner, see what kernel it's running in. If it says something else that's not UNAFCO, please, you can switch the kernel by clicking on kernel. And then down here, there is a change kernel option. And you see there are two kernels that are built, a generic Python kernel and a specific kernel for this class that's called UNAFCO. And make sure that you switch the notebook to the UNAFCO kernel unless it's already set to the UNAFCO kernel. Okay. So I'm going to just go through a few of the code cells of this particular notebook. The way most of these notebooks are built is very early on in the notebook. We import all of the libraries and all of the tools we need to run a specific notebook. So here we import the Python libraries OS, subprocess, and copy. We import matplotlib, which some of you may know. This is a library that allows you to visualize data in a way that's similar to what you experience with MATLAB. If you are familiar with MATLAB code, the way MATLAB visualizes data is very similar to what matplotlib is doing. We use NumPy in, I think, all of the notebooks, which allows us to do mathematical operations on data sets and so on. Some notebooks, like this particular notebook, uses a set of libraries that we built at the Alaska Satellite Facility to make it easier to use certain notebooks. So it uses notebooks from this ASF notebook library. So again, if you want to run this code cell, by the way, there's a trick. If you are like me, I'm not a fan of clicking on buttons all the time to do certain things. The Jupyter Hub environment allows you to use keyboard shortcuts. If you want to know what keyboard shortcuts exist, here in this top icon menu, if you sort of move over slowly, you see an icon that looks like a keyboard. I hope most of you see this. If you click on this little keyboard item icon, it shows you all of the keyboard shortcuts that exist to do certain things. A useful one that I like is the run shortcut. So if you scroll down, there's a shortcut that says run cell and select next. This is my favorite one. You can do it by clicking on Shift Enter, Shift button and the Enter button together. And what it does, it runs a certain notebook and a certain code cell, and then automatically jumps to the next code cell when doing so. So I'm going to try this out real quick. So if I click in this code cell, I'm now doing Shift Enter. And it ran this code cell. You saw hopefully the asterisks as it executed the code cell. And now it has loaded all the libraries that we need for this notebook. So we'll run through this specific notebook later. But again, you see that we throw in markdown cells to give you a little bit of context. So here in this case, we are working with a data set over a volcano called Okmok in Alaska that some of you may know. It's an awesome volcano if you want to do INSAR. It's a very agitated volcano. It deforms fairly reliably whenever there's magma movement going on under the surface. So, every time you calculate interferograms in sort of the snow-free period over Okmok and you analyze them carefully, you're very likely to see some sort of deformation on this volcano. So it's a very nice volcano to exercise your notebook skills and your INSAR skills. So anyway, so this is how you interact with these notebooks. You read through the markdown cells, and you scroll down to the next code cell. When you find the next code cell, you execute the code cell to work your way through the notebook. If you have issues, if you run into problems when working on specific notebooks, and you're not sure whether it's a code issue or whether you had issues interacting with notebooks, there is some help available. If you look on the top row of the Jupyter Hub or sort of your browser interface, you see hopefully a link that's called User Docs. I hope you're all still with me. Maybe a quick test. Give me a thumbs up if you're still around. It's very quiet in the room. Yep. Hey, excellent. So some of you are still there. So if please follow along and click on this User Docs link. So the User Docs pulls up a separate browser tab, and it shows you a bunch of help with how to use the notebook environment. It gives you a little bit of an intro, for instance, of Jupyter Notebooks. You can click on that. It talks to you about these cells that I talked to you about today. It tells you what are markdown cells. Oh, it actually uses that same example. That's funny. It tells you what code cells are and how they work. It tells you how to run a Jupyter notebook. So all of the stuff that we just talked about, it tells you how to do that. There's some best practices for writing a notebook. I talked to you earlier about changing the kernel. There's also some help, I think. Let's see, installing conda environments. Does it show you, Alex, if you're on, where's the kernel switching? Is it in the conda environment section? I surprised my helpers. I'm just going to find out. Oh, so yeah, so here's how you can create additional conda environments if you want to. So all of these things are listed here. Oh, kernel servers and kernels. So it shows you how you can turn off your machine. It shows you how to switch kernels here down here. It's like how do you switch kernels? How do you restart a notebook? All of these things are contained in this user guide. If there are questions that are not addressed here, please let us know either via Slack or via emailing the OpenSARLab team. And if we get enough entries for a certain question, we'll add them to the user guide. Let's see, what else can I talk about? Oh, so maybe going back to the overall OpenSARLab home screen, you see that the notebook that we just run was opened as a separate tab. Your original notebook entry point is still open as a separate tab. So if you go back to that, I want to show you a few more things. I talked to you earlier that there's, for instance, a PowerPoint slide deck on this environment. and you may want to download the slide deck to your local machine. The way you can download data sets is if you want to download an individual data set, you can navigate to the folder where the data set is included. So in this case, you want to download this PowerPoint slide deck. You can click on this little radio button next to it, and you can download, once you clicked it, you can download this file to your local machine. And so it's just opening up a browser tab, and you can download it here. If you wanted to download a whole series of data sets, the best thing would be to do that via the command prompt. And that's the next thing that I want to show you. You can interact with the OpenSARLab the way I just showed you. You can browse through the OpenSARLab like on a Mac Finder or a Windows Explorer to get to the different folders. If you want to, some of you may be more familiar or more inclined to work on Linux machines using command prompts. You can do that also. And so you can always open up a terminal. The way you do it is you click on this button over here that says New. And under New, you can open up certain things. You can create text files, you can create folders, or you can open up a terminal. And if you click that terminal symbol, a new browser tab will open, and you get a little terminal prompt, and you can work on that just as you would do on your, if you SSH into your processing server. And so here, if you wanted to navigate around, you can do that with the usual commands, the CD command to change into a folder, ls to visualize the content of that folder. So here I'm going to show you real quick. I'm moving into the UNAVCO folder. Let's say you wanted to download one subfolder of the UNAVCO folder, and you wouldn't want to click on the individual files separately. You can, an easy way of doing it is, if you have a large list of files that you want to download, is to first zip these files up and then download the zip file with a single click. It's a little bit of a clunky workaround. Unfortunately, the Jupyter Hub environment doesn't have an easy way of downloading large numbers of data sets. So the easiest thing is to zip things up. So what you could do is you could do zip. You give the, I think you have to do -R if you want to zip an entire folder. And then you give it a name, zip file.zip, and saying, I want to zip up the 1.3 in our theory folder. It zips all the content up. And now you have a single zip file. And so if I go to the UNAVCO environment, I see now there's this zip file.zip, and I can click on that and then download that file. So if you have a need, if you feel a need of downloading lots of different individual files instead of individually clicking on them and downloading them one by one, an easy way is go to a terminal, zip it up, and then download the zip file. Let's see, what else can you do? Oh, I talked to you earlier about uploading your notebook. If you have a local notebook that you want to try out in the OpenSARLab, you can, or if you have a file that you want to use on the OpenSARLab, you can always upload those. On the interface, you see on the right-hand side, there's a button that's called Upload. And so if you click that, you can then find a file on your local machine, and you can upload that. I'm just picking some random thing here. It's like a nice little dual pole image of the Galapagos. And so it's going to load that in, and then I can click on Upload to upload that to the OpenSARLab environment, if you choose to do so. I guess one important thing that I wanted to talk to you about is, and Eric, please correct me if I say this wrong. The way the OpenSARLab works is, so we will have all of these coursework that we will do. We'll meet once a day to go through individual notebooks and so on. And then at some point, the class is going to be over. You may be done with the homework, and you may just want to walk away. So in theory, you can just walk away from the OpenSARLab. You can just click that big X and leave the OpenSARLab environment, and everything will be good. What we encourage you to do is to close all of the notebooks that you have running, so that the environment will see that you're not doing anything anymore and will shut down your machine. These machines that are running in the cloud, they are costing money. So if you're not using your machine, we encourage you to close your notebooks and shut down your machine, so that the environment can automatically scale down, and we are not incurring costs with a lot of machines idling. This is not an absolute requirement. If you don't do that, nothing is going to break. But if you think of it, close your notebooks and log out of your machine or shut down your machine, to allow us to quickly spin down the environment and incur the least amount of cost. That brings me up to another topic. These notebooks are saving automatically every few minutes. So if I change something here, say I'm adding a line to this code cell, it will tell me initially that there are unsaved changes up here. Now, if I hastily want to close this notebook, the risk of me losing my change is very small, because it actually doesn't just let me close that notebook. It will say like, hey, you've made some changes that have not yet been saved. Are you sure you want to leave? I could say, yes, I don't care about this change, or you can click on cancel. Now, actually, because it autosaves every few minutes, it actually since has autosaved that change. Let me do another change here, delete this line. So we have unsaved changes. You can click on this little icon over here on the very left. If you click on that, it will save your notebook and make sure that all the latest change of the notebook is saved. And then you can safely close the notebook and walk away. Again, if you forget to click on the save and you have unsaved changes, it will tell you right away, hey, there are unsaved changes. You may want to go back and save manually. So it's a fairly safe environment. It's very difficult for you to lose work that you created.
Franz, can you
Yes, please.
briefly cover the control panel?
Yes, I'm going to show the control panel in a second.
Okay.
So if you're done saving your notebook, you can simply close the browser window. You can also close the terminal simply by clicking on the, closing the browser tab. If you want to know how many notebooks are currently running, or how many terminals you have open, you can always find what's currently running in the running tab. So while in the running tab right now, it shows me that I have a running terminal and I have a running notebook. So even though we closed the tab, the notebook in the background is still running. So you can shut down all of your notebooks at the end of your session. So you go, look up on the running, which notebooks and which terminals are still running. Then you can click on the shutdown, and it will shut down the notebook. And you can click on shutdown, and it will shut down the terminal. If you wanted to shut down your entire machine, you can do that via the control panel. So if you go click on control panel, you have the option of stopping your server, which basically means it spins down your machine in the cloud. There are two reasons why you might want to do this. The one reason is the one that I told you before. If you stop your server, it's going to spin down, and it won't idle in the background while you're sleeping or you're doing some other stuff. So if it's not needed, please stop your server and shut it down. Another reason why you may want to stop your server, let me actually exercise this here real quick for you. Let's see, my server. Okay. So if I go back to my my home environment, I may have done something stupid by accident. Say, in that folder that I was in earlier, maybe by accident I deleted my notebooks. So I clicked on the wrong file, I deleted the wrong file, and deleted my notebooks. And so, for a moment, you might be panicked. It's like, oh my God, I lost my notebook. No worries, as all of these notebooks are actively pulled from a GitHub repository every time you restart your server. The easiest way of recovering a notebook, or for instance, you changed a notebook and you broke it, and you don't know how to get back to the point where it actually worked. An easy way of fixing a notebook that you may have accidentally broken is delete the notebook, delete all the stuff you don't want to have. I'm deleting this here too. And then what you do next is you go to Control Panel, you click on Stop My Server. It will take a minute or so, or a few seconds, to shut down and spin down your server. It will tell you when it's done. So now my server is shut down, and now I can restart my server. And so it gives me a server option. I start the server again. It's going to spin up my machine, depending on if my server is still around. This goes faster. It may take a minute or two.
I think it's worth mentioning here is the current setup is that users are sharing, two users are potentially sharing a machine. And so it's possible that one person might sign on and have to wait for a brand new machine to start up, and it will be it'll take a while. The second person can sign on and they already have that one machine started up, and they just jump right in and be pretty quick. So sometimes it'll take longer than other times to sign on, but generally it'll take no more than 5-6 minutes. But like here, it didn't take that long because the machines are already available at the time, and so he was able to just get right in.
Thank you, Eric. Yeah, so once you're restarted, now I can go back to that folder that I messed up. So I go back to UNAVCO 2021, to that geophysical modeling folder, and you see that my notebook is back. So, all of these notebooks are available on GitHub. They're getting pulled every time. If you by accident delete anything, or you screw something up and your notebook is broken, delete the notebook, go to Control Panel, shut down your server, restart your server, and the information is going to be recovered. A very last thing I may want to show you is the OpenSARLab has a few extensions that you can use to sort of make visualizations of notebooks a bit nicer, or working with notebooks a bit nicer. If you're a developer, if you just want to try out new things, feel free to go to this tab that's called NB Extensions. NB Extensions stands for Notebook Extensions, and it allows you to customize your notebooks in certain ways. You see that there are certain things that are already activated, like Rise is already activated. So that's a notebook extension that allows you to create slide decks directly out of a notebook. You see that the rest of it is predominantly grayed out. If you want to change some of these NB extensions, please unclick that radio button. Once you unclick that radio button, you have access to these extensions, and you can add certain things that you may like. You can click on each individual one of them to get a little bit of an idea of what the different extensions are doing. I personally like collapsible headings. It allows you to organize your notebook a little bit better. It allows you to collapse segments of your notebook based on notebook headings, and organize your notebook, make it a little bit less overwhelming. These notebooks can be very long and may have a lot of exposed codes that not cause anxiety with certain people. So collapsible headings, if you click that on, it would allow you to fold away certain things that you don't always want to see. And so there's a bunch of different cool extensions here. If you're a developer, developers like Scratchpad, let's see where Scratchpad is. Does anybody see Scratchpad? Oh, here. Scratchpad is a cool extension that allows you to debug code. So if you click on a code cell, you can pull up a little Scratchpad on the side and look up variables easily. So it's a really nice way of debugging your code within a notebook and so on. So there's a bunch of really cool things that you can play around with in the NB extensions. I see there's a question. Does shutting down affect the second person? No, it does not. And I hope that's true, Eric.
Yeah, you're shutting when you're shutting down your server, you're not shutting down the AWS machine. You don't worry about the AWS machine.
So if I make any changes and when I restart, my changes will be lost. No, the good question, Vivek. I think I mentioned that early on. The Git puller verifies or looks at every notebook and verifies if it was changed. If the notebook was changed, you added content, you added more code cells, you actually or just ran the notebook and you have output saved in the notebook. It will not overwrite that notebook. It will keep the notebook alone. It will also only pull notebooks back in if the notebook has been updated on GitHub. So if the notebook version on GitHub and the notebook version that you have locally is the same, nothing will happen. But if either your notebook is missing, it's going to pull it back in, or if a notebook on GitHub was updated, so there's a newer version of that same notebook available, it will pull in that new version. If it recognizes that your notebook was touched and the content of the notebook was changed, it will not delete that notebook. It will just copy it to a slightly different file name with a date and timestamp in the end and pull in the new notebook in addition. So your content is not lost. And there's a question for reference material for the pre-course work. It's a good question. I'm not sure if Paul is still on, Gareth is still on. Do you have an answer to the references? Like you mean citations, like papers? We may not have a specific spot for those quite yet, but that's a good suggestion. Selena, thank you. How do we print? I'm getting failures in printing and saving and exporting. Good question. How do you print a notebook? Because in some cases, we want you to print a notebook. Actually, I put specific instructions to that into this 1.2 notebook, but let me show you real quick how to do that. So for some of the homework, we are asking you to print off the notebook and submit your completed notebook. What Emily, I think, is referring to is in the Jupyter Hub environment, there's a file print option, I think, but this print option does not really work. It never really worked that well to begin with, and it also required a lot of backend libraries that made that very clunky. So when you print your notebook, the easiest way of doing it is you right-click. Basically, you use your browser functionality to print the notebook. So you right-click on your browser tab, and you go to print. And when you do that, you can save the document as PDF, and that actually gives you the best, visualization, the best print of your notebook. Better than the internal functionality of Jupyter Hub ever printed it. So for printing, please use the browser internal functionality. You can either right-click and print, or you can go to your, depending on what browser you use. In Chrome here, on the top right, there's the 3 dots, and under these 3 dots, you can also go to print. There's an option of Acrobat on the toolbar. I don't know, Eric, do you know if that works well, the export to PDF, or is that active?
I'm not sure exactly, actually. I've never used it, but I have to
No, it
assume
doesn't
it's
actually
not.
work.
But most of the internal PDF stuff has been either disabled or something like that because it wasn't working well at all.
Yeah, we
So-
disabled most of this because
Browser.
frankly, it was pretty terrible. The PDF versions of the notebooks looked really ugly. So the best way of printing is use the internal browser functionality for printing. Thank you for that question, Emily. And also now that I opened the notebook again, you can see the code folding. I showed you earlier the collapsible headings option that I just activated. What you see now in this notebook is that the notebook now is folded up. So it shows you all the different chapters of the notebook, but the collapsible headings collapsed all the individual, the content of the individual chapters. So you can work through this chapter, you can close it again, you can then work through the next chapter, and you can close it again, and so on. So it allows you a little bit to organize your code. Okay, I think that's all I had, and I'm actually pretty much exactly at the end of the hour. Sorry for babbling and droning on for a little bit. There are some questions. I see a couple of raised hands. Attar, do you want to speak up or do you want to type it in? Not sure if these raised hands. Forrest, you also have your hands up. Do you still have a question, or was that an old question? Yeah, maybe that's maybe these questions have passed. Oh, okay, excellent. So this is going to be recorded. We will switch the recording on the syllabus with this new recording. So next time, probably later today, this switch will happen. Is that correct, Rebecca? Can you switch that today?
Yeah, it'll either be today or first thing tomorrow, but the link should be ready fairly soon.
Carolina, yes. So actually, when you print using the browser functionality, it's going to print directly to your local machine. It won't actually print to the OpenSARLab. So you can print the notebook off once you are completed. There will be instructions. I think most of the homework assignments have specific instructions. I hope mine does. So brag. On how to submit the homework. If you're unclear, post a question on Slack and we'll get back to you.
Also add, so when everyone signed up, they received a via email, a confirmation code and other stuff. That email was UAF Jupyter Hub ASF / navco@alaska.edu. If anyone has any problem signing in that they can't overcome, or if there's this weird errors popping up everywhere for some strange reason, don't be afraid to use that email to contact us to say, hey, I got this problem. Maybe include a screenshot so we know exactly what you're talking about. And we will try to figure out the problem is and solve it so you guys can get on and do your classwork. That's what we're here for. So, yeah. Oh,
and we forgot one thing. I know we already over time. End of life. So the UNAVCO setup that we deployed at unavco.asf.alaska.edu, that one will be available for you throughout August, throughout the class, and we'll keep it running for an additional week after the class. Toward the end of the training, there's two ways, sort of end of life policies we have. One of them is many of you may want to long-term run all of this stuff in your local machine. Our experience is that sort of the geoscience community, you want to have control over your code and you want to own all the code you develop. So there's going to be a Docker container-based option that allows you to deploy the content of the OpenSARLab to your local machine. We'll have some information for you toward the end of the training. If this is not an option for you if you don't have the compute environment locally, or if there's some other reason for you to really want to continue on the OpenSARLab, we can have a conversation afterward via email to figure out how to make sure that you can do your work and continue to do your work after the end of this training. So on a case-by-case basis, we'll find solutions for all of you to make sure that the people that need access to certain environments will have an option to keep access, and the people that want to run it locally will have an option to run things locally. So stay tuned for those updates as we go along with the training. I think that's all I had. Thank you all for your attention. And I'll see you off and on Slack, and latest next week when we do the training. See you all.